given that we have gone over how we can actually use the power rule to solve integrals in the previous video, and if you haven't, I suggest you checking out the previous video on intro to integration, so you can really fully understand what integration is about. But just to recap, integration, the power rule for integration is quite simple. For example, we have the equation x power 5. We have the integral x power 5 dx. If we want to solve this, the indefinite integral, what we can do is to actually equal to x power 5 plus 1 divided by 5 plus 1 plus c, because in the indefinite integral we must always add a constant at the back, and then evaluate as x power 6 over 6 plus c. In this situation, the reason is because, okay, let me explain. As an integral is basically an antiderivative, and it is which means it is basically the opposite of a derivative. So remember that a derivative of, let's say we have derivative of x power 6 dy dx, sorry, y equal x power 6 dy dx equal to, so we bring down the x and multiply x power 5, and then on the other hand, when we integrate x power 5 dx, what we get, if we take out the 6, then take x multiply 5 plus 1 divided by 5 plus 1 plus c, and we get 6x power 6 over 6 plus c, and we get back x power 6. Okay, now that we've gone over this part of integration, now let me show you what integration by U-substitution means. And basically, integration by U-substitution, integration by U-substitution is when we use U to substitute into a very complex equation to solve the integral. Example, alright, let's say we have the integral of x squared minus 1 power 5 multiplied by 2x dx. If we use the typical power rule, wouldn't it be quite challenging to solve? Now, okay, what we have here is a very powerful tool, the integration by U-substitution. Now, what we do, we see that the very hairy part of the equation is actually x squared plus 1, right, with the power 5. So what we do, we let U, we let U equal x squared minus 1, this part, right? And then we differentiate U, right, in terms of x, du equal 2x minus 1, 2x dx, right? And what we notice here is that, oh yes, our du 2x dx is equal to this part, right? So you can essentially cancel it out. So what we get afterward, let me change back the color. Okay, what we get afterwards is we get integral of U power 5, because we have this, right? U equal x squared minus 1, so U power 5, and then we just take 2 du, because du has essentially cancelled out, this part has essentially cancelled out, right? So we can just easily solve using the power rule here. So we get U power 6 divided by 6 plus c, right? And then always remember to substitute it back, right? So U power 6 equal x squared minus 1 power 6 divided by 6 plus c, and that is your final answer. Now let us move on into more different complex equations. Okay, example for here, for question 1, okay, we see that they have given you the U, so it's very simple. So what we do, if we write negative 15x power 4 negative 3x5 minus 1 power 5 dx. And of course, you see, they gave the U as this very heavy equation right here, right? So what do? Let U, just copy along 3x power 5 minus 1, and differentiate u equal negative 15x power 4 dx. So you notice that both sides cancel out, right? So you can cancel it out, and then what you get? Ta-da! You get u power 5 du. And then, as the same, just use the power rule to integrate it, u power 6 over 6 plus c. And always remember, do not forget to substitute it back, right? Plus c. And that is your final answer for this question. Okay, now let us move on to the third question. Now, this is a lot more heavy, right? But don't worry, we will be able to solve it. So, integral of negative 8x power 3 divided by negative 2x power 4 plus 5 power 5 dx. Okay, they gave us the u. So, the u always the heavier equation on the bottom. So, u equal, let me change the color. U equal negative 2x4 plus 5 du equal negative 8x power 3 dx. Now, what you notice is, okay, before that, what a trick I always do when I do integration is that I separate quotients. What do I mean? I take out the x, negative 8x power 3, multiplied by 1 over negative 2x4 plus 5 dx. This makes it so much easier, and you prevent making a lot of careless mistakes by doing this alone. So what you notice is that the du, the du is negative 8x power 3 dx, and we have 8x power 3 dx here. So it essentially cancels out, right? So we are left with this equation here. So what do we get? We get 1 over u power 5, always remember, don't forget the 5 here, right? Du. Okay, so, well, another easier way to write it is by u power negative 5 du. Okay, remember that 1 over u power 5 equal to u power negative 5. It's the same thing, right? Okay, now just use the power rule here, and we get u power negative 4 divide negative 4 plus c. And if you want to simplify it, you can go, pardon me, I'm running a bit out of space here, negative 1 over 4 u power 4 plus c. And then always remember to substitute it back to negative, so you get negative 1 over 4, and substitute the u. Our u is negative 2x 4 plus 5 power 4 plus c, and that is your final answer. Now, moving on to the last question of this video. It's a bit more challenging, and you have to find out the u for yourself, but I suggest you giving it a go. Given that you have given it a go yourself, let me get into solving it. Right, you have the integral of e power 4x negative 4 power 1 over 5 multiplied by 8 e4x dx. Wow, okay, now this is very heavy, but don't worry, you'll be able to solve it, trust me. Okay, now we let u. Now let us find what can we actually substitute with u, right? So, what I noticed, the heavier equation here, as in the more tough equation here, is this part, right? E4 power 4x minus 4. Because it has a power on top, it's very hard to expand and do any sort of expansion. So, what we take this part, e power 4x minus 4, and we differentiate, right? We always remember, differentiate e, copy for exponential, multiplied by the derivative of the top part, multiplied by 4 dx. Because negative 4, the derivative of negative 4 is 0. So we get 4 e power 4x du equal 4e 4x dx. And now you notice 4e 4x doesn't exactly cancel each other out. So what do we do? Very simple. Multiply both sides by 2. You can always multiply both sides by 2. And what you will get? you will get 2 du equal 8e 4x dx. And then, yes, exactly, now 8e, and you get 8e 4x dx. And just exactly, now that you get it, it cancels each other out, right? So you got t2 du, right? Now back to the we will go on the other side. Okay, 2 du, remember we have the integral of, we have substituted u for e power 4x minus 4, so we get u power 1 over 5 multiplied by 2 du, and we always can take the 2 out, equal to 2 integral of u power 1 over 5 du. And as always, it's very simple from here. Just use the basic power rule. Equal 2 multiplied by u power 6 over 5, because 1 over 5 plus 1 is 6 over 5 divided by 6 over 5, and plus c. And then you can always simplify. 2 divided by 1 divided by 6 over 5. Get 5 over 3 multiplied by 5 over 3 u 6 over 5 plus c, and always substitute it back, which is e power 4x minus 4 6 over 5 plus c, and that is your final answer.